Okay, please take down. Find the weight on the front wheel and the rear wheel for a car weighing 2000 kgs. For a car weighing 2000 kgs. The CG is at a height. CG is at a height of 1 meter from the ground. 1 meter from the ground. 1 meter from the ground. And behind the front wheel by 1 meter. Behind the front wheel by 1 meter. Behind the front wheel from 1 meter by 1 meter. Wheelbase L. Wheelbase L. Wheelbase L is 2.5 meters. Wheelbase L is 2.5 meters. The aerodynamic drag is considered as, the aerodynamic drag is considered as DA is considered as 500 Newton. 500 Newton. The car is climbing an incline, the car is accelerating. The car is accelerating. The car is accelerating by 0.5 g. The car is accelerating by 0.5 g. By 0.5 g. In an incline of 5 degrees. An inclination of 5 degrees. An inclination of 5 degrees. Hope so. Now the data may be sufficient. If you actually have any missing data, we will try to give the data as and when it is required. Guys, you just have to use this equation now. So can you use this equation and find out? So weight on the front wheel. You just have to substitute the values. Here, if you know the weight on the front wheel, I mean weight divided by weight of the front wheel will give you the weight of the rear wheel also. So you can find out, so you can substitute these values here. So weight is W, it has to be substituted in terms of newtons or whatever. You please try to find out. If one is in newtons, everything has to be in newtons. So it is force. So all these are actually forces. So here this weight divided by this will give you, so weight in kgs divided by g, 9.81 meter per second square. So you will actually have to find out the mass. So you know that weight is nothing but mg. So you can find m. You can find m there, which is w by g. So here we are actually trying to say this. So this is mass. Mass is in newtons. Mass is in newtons. So everything you try to convert this into newtons. The force, the weight you convert into newtons and then try to solve the problem. So 2000 kgs is how many newtons? So multiply it by 9.81. So kg meter per second square is. So what is the value here? Huh?
You got HX.
HX. Huh? HA. Okay. Okay. As and when it is required, will give it. Okay. Okay. Wanted? HA. Okay. So at a height of aerodynamic drag 500 Newton at a height of maybe 0.7 meters. and also hitch is not there. Okay. So let us now consider this. Guys, W 2000 into 9.81, how much, man? 19,000? 620 newtons multiplied by length of the car. What is the length of the car? 2.5 meters. 2.5 meters. So 2.5 meters. And this is Newton meter. So we are actually substituting some of the moments. So now.
Sir, we can't substitute front to it.
Okay. Sorry, guys. So this is no. Sorry, we're supposed to find out W. Okay. So WF. So we're supposed to substitute here. Wait. So again, you can write it as so WF into L. So WF into L. L is actually 2.5 meters. That's plus. So DA is 500 newtons. 500 newtons at a height of how much? 0.7 meters. And this plus W by G. So that is 2000 kg. Divided by 9.81 meter per second square. Guys, you know that 1 Newton, you know that 1 Newton is 1 kg meter per second square. The same thing you're reading here. Okay, this is becoming ulta. Kg meter per second square. Sorry, here this is G, this is acceleration is again G. Okay, here this is, sorry. Guys, 1 minute. Sorry, I think we made a very fundamental mistake here. So when we say weight of car is 2000 kgs, that is actually the mass of the car which I have given. Weight is actually the force that is felt by the mass. So if I got a weight of around 2000 kgs, the force that is felt is 2000 multiplied by 9.81. So that is weight. So here this W by G can be directly written as M. It can be directly written as M here. Okay. So that's a small mistake we have done here. So you try to take this directly as mass is equal to 2000 kg. Mass is equal to 2000 kg. So 2000 kg multiplied by acceleration will give you newtons, because Newton unit is kg into, kg is mass multiplied by acceleration meter per second square, that will give you newtons. So here Newton multiplied by distance, here Newton multiplied by distance, here Newton multiplied by distance. We are all multiplying Newton into distance, force into distance, force into distance. We are trying to take clockwise moments and anti-clockwise moments. So everywhere the first term has to be Newton. So you please take this as mass is 2000 kgs. Mass is 2000 kgs here. Don't divide it by 9.81. That was a mistake. Mass is 2000 kgs here. Multiplied by A. Acceleration is 0.5 g. So 0.5 g is how much? G refers to how much? Okay, acceleration due to gravity, that's 9.81. That is 4.9. Okay, we will approximate it to 4.9 meter per second square. So that is acceleration is 0.5 g. Okay, and then plus W sine theta. So weight. So here we set it as mass is this one. So weight is what? Weight is m into g. Weight is m into g. So here we need to convert this into weight. Weight is sorry. Here we set this W into A. You have forgotten H. So what is HM? 1 meter. 1 meter, and then again one plus, and W is m into g. W is m into g. So m is 2000. So here only you write. So 2000 kg multiplied by 9.81 meter per second square. What is the weight?
19620.
Huh?
19620.
19620 newtons. So that is newtons. 19620 newtons. Actually sine theta. Okay. Sine theta. So theta is 5 degrees into h. H is how much?
1 meter.
H is at the height at which the center of gravity is there is 1 meter. Okay, 1 meter. And then W sine theta into H minus W cos theta. Minus W cos theta. Okay, is it visible? So W cos theta. So W cos theta is 19620 newtons. Cos theta. Okay, so we'll try to put this here. Minus 19620 newtons. So for W cos theta, W is 19620 newtons. Cos theta, so cos theta is 5 degrees into C. C is how much, guys? Guys, length is 2.5 meters. Length is 2.5 meters, and the center of gravity is how many meters from behind the front wheel? 1 meter. So what is C? 1.5. So this is 1.5 meter, and then I said in this case there is no hitch. I said in this car there is no hitch. No hitch means these two forces are not there. This is 0. So you find out. So here all terms are there. All are numbers except this WF. Please find out. Guys, people don't have the habit of bringing calculator. So many do not have calculator now. Huh? 691 ಅಲ್ಲ ನಿಮಗೆ ಇದು WF ನ್ಯೂಟನ್ಸ್ ಅಲ್ಲಿ ಬರಬೇಕು. $6,000? Okay. Guys, ಎಲ್ಲರಿಗೂ ಕಾಣ್ತಿದೆಯಾ? Okay, now we have got this WF. One of the student has got the answer. It is 6,500 kgs. Newton, sorry. Guys, here you can see, suppose if the car was not accelerating, now total force acting on the car is 19620 newtons. It is not even half, less than half, because the car is climbing an incline. It is accelerating. So most of the weight has got shifted to rear wheel. Most of the weight has got shifted to rear wheel. So therefore the weight on the front wheel is very less. Out of this 19620 newtons, only a small amount of force is left. So weight on the front wheel is 6,500 newtons. Weight on the rear wheel 19620 minus 6,500. Is it actually exact 6,500 banta? 6,900. 6,900. So you got 6,900. 6,983. So be precise, guys. It is 6,983 newtons. 6,983 newtons, and weight on the rear wheel is the total weight minus the front wheel weight. The total weight minus the front wheel weight. So that is the rear wheel weight. So how much is the rear wheel weight?
12,637.
12,637. Guys, now for this car, if this acceleration, suppose if this acceleration was instead of not 0.5 g, suppose if this was not 0.5 g, if it was like a formula car. Now what is the maximum acceleration in a formula car in terms of g? Okay, it is actually 3g. Suppose if I make this as 3g on this incline, then this weight on the front wheel could have come less than 0. So which means that you literally need to pull the front wheel downwards to keep it on ground. Okay, so that means the front wheel would have lifted off the ground. So that means the car would have done a wheelie. Okay, the car would have done a wheelie. So you see here, with higher and higher inclinations, with higher and higher accelerations, okay, the car weight would start shifting to the rear wheel. Sorry, it would start shifting to the rear wheel, so the front wheel will become lighter. Even though CG is nearer to front wheel than the rear wheel, front wheel to CG is 1 meter, CG to rear wheel is 1.5 meter. Even then there is more weight shifted onto the rear wheel. It is because of this acceleration, inclination, air drag. Of course, if there was a hitch, it would have still contributed to front wheel lifting. Okay. Like this, I have just solved a single problem. I can give different types of problems.